Yes. Good afternoon, everyone. So welcome back to our day 2 session, second session on the disease surveillance and outbreak analytics with R. So which we actually started yesterday. So just a quick recap of what we talked about yesterday. So yesterday we talked about cleaning our data. So we are giving a dirty data, which is actually surveillance data that was collected on sites. So we first of all, we even talked about R. We look at some of the windows in R, the basics of R. We also talked about some of the basics of R. We also talked about packages, how you can install packages. Then we now imported a messy data. So the case scenario that we are talking about, which is about dysentery. So we imported the data and we cleaned it. We did a lot of cleaning yesterday. We cleaned column names, we cleaned duplicates, we cleaned categories, we cleaned ages, we cleaned word, we also cleaned the dates. And at the end, we had a clean data which we actually work with or visualize. Then we decided to save the data as AWD line list clean in class.csv. So this is what we saved it as. So today we are going to answer questions from this particular data. We are assuming we are the surveillance team and we want to know who is affected, where is being affected, when, and also how severe. So who is affected, where is being affected, when, and how severe is the place that is being affected. So this is what we're going to be looking at today. So what are you going to learn today? So first of all, we're going to be looking at how to create descriptive tables, such as age, sex, and word breakdowns. So how do we create such tables? Secondly, we'll be looking at epidemic curves, which is the most important outbreak graphic. So we're going to be looking at an epidemic curve. What is it? And also, how can we plot one in R? Then next, we'll be looking at key outbreak measures. So what are the key outbreak measures that we have? So attack rate and also case fatality ratio. What are they? And also how can we plot a simple trend line, which is a moving average, and a one-page surveillance summary. So we're going to be looking at a one-page surveillance summary. So these are the things I'm actually going to be looking at today. So we're going to set up and load our clean data. So I think, first of all, before we do that, we need to ensure you already have these libraries. So ensure you already have these libraries. So the first library is tidyverse. Then the next is janitor. I think we also loaded janitor yesterday. Then we also have lubricate. Then we also have skills. Yes. So these are the key libraries that we're going to be using today. So first of all, you load our data, so our clean data. So we're going to load our clean data. If you don't have the clean data, which you saved yesterday, we will also share the data, so you can just decide to use this. We're going to be loading 2 data. So we have 2 data here. First of all is world population CSV. We are going to be using this to calculate our attack rates, also case fatality ratio. Then we also have the data we cleaned yesterday, which is the AWD line list clean in class.csv. So if we don't have this, which we saved yesterday, you can just decide to load this. I think this was also shared in the chat yesterday. This AWD line list clean.csv, you can decide to just load this. So we're going to be loading these 2 data and with our library. So let's load them. So you can see we have our line lists. We also have our population. So once I click on line lists, these are our clean line lists, just like we had yesterday. This is it. our clean line list data. So we have already cleaned it to the best of our knowledge. Then we have population. This is also another new data that we're going to be using today. We have the word, we also have the population. So the population in each word, this is it that we have currently. So we're going to get a glimpse of our data. So I talked about the glimpse function yesterday. It just allows you to just find information or just get a summary about your data. Just from the name glimpse, you just look at what your data is, how does it look like. So from here, you can know which ones are characters, which one are dates, which ones are categories, which one are also reports. So now, descriptive table is what we're going to do.
Excuse me,
Yes.
before you go ahead, there's somebody raising his or her hand. The Salma. Please go ahead.
Hello, good afternoon.
Good afternoon.
Yeah, I think I just sorry to send you a little bit back. I wanted to remember how you saved the data we finished working on yesterday. There was a quick shortcut you did to save what we had worked with. I wanted to remember. Thank you.
Okay, so this is the one script. This is the line. This is it. Use write CSV. So you already have your variable. Your data is already in a variable as a data frame inside your inside R. So you now want to export it as CSV such that you can open it in Excel or any other tool outside. So this is the function you're going to be using, write CSV, write underscore CSV. So the first thing that I'm going to put in the function is going to be your variable. That is the data, that particular variable that you already have. That's what's going to be the first. Then you now say comma. Then the next will now be your what? File path. Your file path. Where are you storing it? So are you storing it in a folder or you are just storing it in the project? So this file path is for your project, not for your system or PC. So you want to store it now, like this is my project now. I want to store it under data. So I'm now going to write data slash then the name that you want to give it. This name that you see is the what you want to give it. I can decide to say A. I can decide to say A like this now. If I run it like this, and go to data, you can see that A is already appearing in this place. So that's file path.
So the line list, that's the name of the data now that it's here, right? The line list.
Yes, that's the name of the data. That's the name of the data as a variable that you are working on.
Okay.
Why the green one is the name you want to give it as a file. The name you want to give it as a file. That's the green one.
Thank you so much.
You're welcome. Okay, so I think we're done with the setting up and loading of our data. Then the next we're going to be looking at a descriptive table. So yesterday we talked about the table function, and I told you that it's actually used for quick frequency tables. So it's used for quick frequency tables. You don't just build a frequency table quick. Maybe frequency table based on sets or based on word or maybe based on another particular categorical variable. It's simple, it's readable, and it also makes your table presentation ready. So if we just check our number of rows, you can see our number of rows currently is 296. Our number of rows is 296. And we also want to check our range for our dates. What is the range of our onsets? So from what to what are we dealing with in terms of date onsets now? So in terms of date onsets, we are dealing with 5th of January 2026 to 3rd of, I think this should be July 2026. So this is how you can check for your range. You use the range function. Then there's this thing we call $sign. It's actually used to refer to your column. So I think I've used it yesterday. So let me just explain more about it. So when you have a data frame like line lists, and you have a data frame now like this line list, you now want to access your column. You want to bring out only your column. You use the $sign. Shift your $sign on your keyboard. Once you put the $sign, automatically you see all the columns in the data. You can see all the columns now in the data. You can even use your enter key to just pick one of them instead of typing it. So I can just put reporting delay. So, and when I enter it, these are all the values under reporting delay. These are all, so it comes out as a vector. I talked about vector yesterday, that is a collection of values of the same type. If you have characters together and you want to create a vector of characters, everything has to be characters. If you have numeric, everything has to be numeric. So when you use the $ on your data frame, so first thing you type is the name of your data. You type the name of your data, then $, then you now put the name of your column. So this is how you actually access a column inside a data frame. So that's what we just did in this place, because this range needs a vector. You can't put a single value in the range. It actually needs a vector. So that's why when we now put all of this, it's just like putting all of this inside here. So that's what we just did here. Like putting all of this inside here. So then you now get the range of the date onset. So you can try it with any other variables. If the variable is numeric, it only works because the range actually takes numeric vectors and not character vectors. So we have our case counts. We have our case counts by sex now. So we want to count our cases by sex. I already explained the table yesterday. So if I just call table itself, let's say I say table line lists, comma, sex. If I just call this alone, you can see that I'm having a frequency. I'm having a frequency. And it's also telling me valid percentage. So this is like just percentage of observations that are female, percentage of observations that are male, with reference to the whole total number. That's what it's having in this place, with reference to the whole total number. So you can see we have two types of percent here. This percent is with reference to everything here, while this one that you're looking at here is with reference to just these two, because this one is not actually valid. So this one is just with reference to missing observations. So, but in terms of, if you check 163 plus 122, if you divide 163 divided by, if you say 163 divided by 163 plus 122, you are going to get something like this, because it's no more considering this NA. So that's why I can see it's called valid percent. Why this percentage is actually considering the missing observations. So this is how you can just get a simple descriptive summary from your data. So next, we now have a function called add-on PCT formatting. Add-on PCT formatting. So what the add-on PCT format actually does is that it's no more, it now gives those percentage that you saw earlier on. Can you see them? They are the same table. So instead of them to be they're actually in percentage, so that they are represented like as in a proportion. So it's when you multiply it by 100 that it now becomes in a percentage format. So if you want it to be in a percentage format, you just pipe it to this particular function, add-on PCT formatting. Why this one is the number of significance figures. If I put 0 here, for example, now, and I run it, you can see now it's to the nearest whole number. If I put 3 or 2, let's say 2, you can see it is going to approximate to 2 significant figures. So this is how it works, this add-on PCT formatting. This is how it works. So we also have case counts by word. Case count by word also, just like we did earlier on. If I'm to pick this now and I run it, so you can see I also get the same thing, just like I did with sex. Now, if you want it to be, it's now scattered, it's not arranged, because one thing with analysis, you always want it to be easy to understand with the eye. So it should either be in descending or ascending order, so that when somebody sees it, you know that, okay, once I'm going down with my eyes while looking at the table, I'm going to be looking from bottom to top or top to bottom. So I'm going to do it in descending order. So we talked about this yesterday. You use the arrange function. That is if you want to do it in ascending order. But if you want to do it in descending order, you now have to put descending inside the arrange. You have to put descending inside arrange. And because in this table already has an n, you are descending by this particular value. Then you now put what? You now put n inside the descending function. So when you run this now, you can see it's now in descending order from the highest to the lowest. So if you have like another variable that was here that you wanted to what? You wanted it to follow to be in descending order, then instead of n, you put that particular variable. Say, let's say, for example, now you now had something like age. So instead of putting n, you put what? Age. So this is how you can use the arrange function or the descending function. This is how you can use it with the tabby function. So I'm just going to run this. Okay, yes. So we have what we call a cross tabulation. So cross tabulation is now when you have two categories. Those tables I've been looking at was just only one categories. But there are some scenarios whereby you have two categories. You have sex, you have word. So how can you display information when you have two categories? This is where you use cross tabulation. So this is the cross tabulation that we have here. If you want to build a cross tabulation, first of all, you have line lists. Then you pipe in your tabil. Now, tabil is not going to be taking one because you are doing a cross tab. You are going to be doing a cross tab, which is two categories. It's going to be taking two categories. So I'm going to be using.
I hear machine.
Hello, please mute the mic. So, tabil is going to be taking two categories: age group and sex. This is what tabil is going to be taking: age group and sex. So when I run this, you can now see we're having what? We're having a cross-tabulated, we're having a cross tab. So how do you know it's a cross tab? If you look at this is our sex. If you now look at this, our columns is going to become sex and age group. So can you see when I switch it, it has turned. When I switch it now, you can see it has what? It has flipped. So the sex is now the columns. Why the what? The rows is now the age is the columns, while the sex is now the rows. So let's go with the way we had it earlier on. So this is how you can build or create a cross tab using the tabil function. Then next we now have add-on totals. So what do we mean by add-on totals? So I think let me do this other cross tab that we had. So what do we mean by add-on totals? Add-on totals means sum my columns or rows. In add-on totals, you can specify two things or even specify any of them. You can either specify your row or column. That means give me both row and column totals if you specify your row and column. Or if it's only row, you can say give me row totals. So row totals means each of these is going to be summed and you have the value here. So let's say, for example, now let's start with row total. If I'm to say row total. So can you see now I'm having what? Row totals. My row totals. So this is it. So column totals is going to be sum of this. You have it here. While row totals is going to be sum of each row. You have it in this place. Currently now this is row totals. You can see the total here. So I'm going to say 7 plus 50 plus 20 up to 19. You have it in this place. And you can also say 12 up plus 38 up to 10. You have it here. You can decide to specify only column totals by writing column and you run it. You can see column totals now. 7 plus 12 plus 1. 50 plus 38 plus 2. Can you see it? Up to the missing value. You can see the value. You can see the column total here. So if you want to specify for the 2, you have to now use your concatenate function. Just like I told you that when you're combining more than one values, you need to use the concatenate function. Then row. So this is it. Now, we now what? We run it. So you can see I'm having both what? Row totals and column totals. So this is how the add-on totals actually works. Then the next, we have add-on percentages. add-on percentages. So add-on percentage is going to can also apply it either row or column. So can you see it now? Add-on percentages now. Add-on percentages. So percentages can either be calculated either in row or in column. In terms of row, it's going to what? If you look at this now, the total of all of this is 1. The total of all of this is 1. The total of all of this is 1. It's going to calculate the percentage row-wise. So that means female plus male plus NA. Then it will now calculate the percentage. So it's calculating the percentage row-wise. If I should change it to column now, it's going to calculate the percentage column-wise. So you can see it now in terms of column. You can see the sum of this plus this up to this is going to give us what? 1 in terms of column. So we now need to also put the add-on PCT formatting to make the percentage sign show and also make it in a percentage format. So just like I explained earlier on. So let me just switch this back to row. Okay. So now, this is now it. So I've already applied add-on PCT formatting. So you can see how it's appearing now. 35%, 55.6%. So you can see 35 plus 60 plus 5 is going to give you 100 because this is row-wise. This is row-wise. If I have to change this to column, you can see it's column-wise now. You can see it is now column-wise. So this is how you can play with either the add-on percentages or the add-on PCT formatting. Then we also have add-on NS. So this is the add-on NS. So add-on NS, what it does now is that it gives you both the total and also the percentage. So if you can see earlier on, we're having only just percentages. But most of the times in a report, you need to give both the total and also percentages. So you can see percentage of female, you can see percentage of male. You can also see their values, the real values itself. So this is how add-on NS works. So it's actually applied after I've already applied the add-on percentages and also the add-on PCT formatting. So this is it for this particular part on how you can use your cross tabulation. Is it clear before I proceed?
Very clear.
Okay. So I think we also have one more. So this one is, so I think we can understand this one based on the explanation I've already done earlier on. We have the tabule, which I told you, you can, if you give 2 values, then it's going to give you a cross tabulation. If you put a single, it will only give you a frequency table. And you also have your add-on totals. So when I run this, hospitalized, I don't know what's happening. By my dog. Okay. So this is it. Hospitalized, we have a variable called hospitalized in our data yesterday, and we also have outcome. So you can see a cross tabulation of it. This is how it's going to look like. So it's very easy if you want to build a cross tab using this particular tabule function. So next, we're going to be talking about an epidemic curve. So what do we call an epidemic curve? So an epidemic curve is usually the first graphic that is shown in any outbreak report or site report. So it tells you at a glance, situation report, sorry. It tells you at a glance if the outbreak is growing, peaking, or declining. So an epidemic curve is just more or less like let's call it like an histogram, because on your x-axis, you have your dates. While on your y-axis, you have the total number of outcomes that happened, or total number of cases that happened that particular day. So Monday, or let's say 1st of January 2026, we had 5 cases. So it's like we have a bar. We also have another bar that will now record the case of the next day up till the months which you're actually stopping or you're looking at the cases. So that's what just an epidemic curve looks like. So you can look at if the outbreak is growing, peaking, or declining from an epidemic curve, because where there's a peak, you will find that the number of cases was high in that particular day. And its transmission is single point source or it is ongoing. That is the transmission. And also roughly when did the exposure or transmission actually what occur. So these are kind of cases, these are kind of things you can actually look at your you can actually look at your epidemic curve. You can see from epidemic curve. So let's look at a basic epidemic curve. This is just a simplest version. So this is the simplest version, daily case counts. So we want to look at daily case counts now. So let me just plot it before I explain. So this is the data. You can see epidemic curve, suspected AW cases, Ogun North local government area by date of symptom onset. So any place you do not see a bar, this actually means that there was no cases in that particular day. So you can see the number of cases on your y-axis. Then when you look at your x-axis, you see your date of onset. So you can see January. So January, February, March. This is April. This is July. So you can see that around, this should be June. May, June. May, June is around this place. You can see that we have a peak. So that means cases were actually high around this particular period. So this is just how a simple epidemic curve looks like. So someone might actually wonder, why is it called a curve and we're actually seeing bars? So the thing is that you can actually draw a line in this place. That line that is being drawn, it shows the distribution of how the disease has been progressing. So that line is going to give you a shape. If you have to draw a line here, you're going to get a shape. So that place where you see that is very high, that is actually the okay. So now this is our code that we used to plot that particular graph that we had earlier on. Okay, so I'm seeing some messages in the chat. Hope it's not questions before I progress.
No questions. It's just those who didn't get the email yesterday. So I've attended to it.
Okay. So we have the ggplot2 package. We have already loaded it with tidyverse. It comes with tidyverse. So the ggplot2, it comes with tidyverse. So so the ggplot2 allows you to be able to plot graph using the layers of graphics. So, but the thing is that one might be wondering, you are seeing plus, why are we not using pipe operator? So ggplot2 actually came out before the pipe operator was created. So it was very difficult to decide to say one want to change the whole code of ggplot2 to start using pipe operator. So that's why the ggplot2 still uses plus to today. So the ggplot2 uses plus. So if you are piping your data to ggplot2, you can use the pipe operator. But once you start using ggplot2, you start piping using plus. So that was what was used before the pipe operator. So you use the ggplot function. The first thing it takes is line lists. Then we have what we call your coordinates. You declare your coordinates. And our coordinate is what? X is equals to what? Date onset. So we are counting date onset. So each date that we have on our data, we're going to be counting total number of cases for the using. So, you know, our data come in record of patients. That's the way our data came. If you look at this data now, you can actually have 4 individuals that have cases on the same date onset. So what we're just basically doing now, we're plotting a histogram of the date onset. I told you that the epidemic curve is an histogram. So that histogram is what we are trying to plot. Well, I don't know what happened. Okay, is everyone seeing my screen and hearing me? I don't know what happened. So, are we there?
Yeah.
Yes.
Okay. Okay. So,
Yes.
so date onset. Date onset is sorry, we are trying to plot an histogram of the date onset. So I told you that this is our data. It comes in records of by that's each record is a patient. So the date onset, when we want to plot an histogram, we're trying to now find how many cases do we now have. So if we can have, like, now look at this. This is 20th of March 2026. We can have 4 more patients with this same date onset. So we'll just count them. I'll say 5 people on this day, the next day 6 people. So that's what we're just trying to do. So that's why you can see we are giving only 1 coordinate. So automatically ggplot2 is just going to count the dates. So how many dates do we have in this particular data? That will now represent the total number of cases for that day. So when you run it like this, you get an empty graph, because I told that ggplot2 works based on the layers of graphics, grammar of graphics. You build in layers. So first of all, you can see, you get this. So you can also write it like this, line lists. Then use your pipe operator. Then you say ggplots. Then you now see aesthetics. Then X is equal to date onset. It also works like this. They are both the same thing. Anyone that's comfortable with you can write that. So this is the first layer that we have now. Layer 1. This is it. Then the next, you use your plus sign. You now say this next one is where you declare the kind of graph you are trying to build. If you want to do a bar, you use geom bar. If you want to do a histogram, you use geom histogram. We have various types of graphs you can build. All of them, most of them should start with geom. We have geom density. You can see them. If you just type geom, you can see all the available plots that you have. You can see there are a lot, depending on the type of plot you're actually trying to build. So I'm going to be using geo histogram in this case. And the bin width of the geo histogram is 1. So bin width is more or less like the spacing of the bars in your histogram. And you are giving it a color fill is equals to steel blue. You can decide to use any color you want. You can just decide to use red if you want. Then color is equals to white. So when we run this, you can see this color that you're looking at is the outline of your graph. Why this steel blue that you're looking at? This color is equals to white now. We have to remove this. You can see now there is no more that outline again. The outline is no more there. So that's just how you can customize the bars. Use color for the outline, use fill for the fill color. Then the next is our labs. So this labs is a short form for labels. That's what labs means. Once you see labs, it means labels. If you look at our graph now, even without using labs now, you can see this is our graph. So this is our graph. Without using labels, you can see that just our variable name is appearing. But this is something you want to show people, or maybe you want to show as a reporting. So you can't just use you can't just use it like this. So you need to change it. That's why you need to start fixing your labels. You need to start fixing the labels, and also you need to give your plot a title. So that is where the labs function comes. So the first is title. Title is what is going to show on your plot. So this is the title, which I'm just going to give here. Then the next we have is subtitle. Subtitle is just a smaller text that will show below your plot and below your title. Then we also have your x-axis. Which name do you want to give it? So the name I want to give it is date of onset. That's what I want to call it. Then I have my y also, which is also what? Number of cases. So this is the two. Date of onset and number of cases. So once I run this, you can see I have my graph. Then we now have a setting called team minimal. Team minimal. So this is the team minimal. I can see you just use to control your data. It's just like more or less setting your contrast on your team. So you can see when I run it with the team minimal, I already have my epidemic curve. So let me run this again. So this is it. This is our curve now that we have. So this is just the procedure you use in plotting. You use this same procedure for plotting any kind of graph. The only thing that will be changing most of the times is just this. Most of the time, this is what will be changing. And sometimes it's a graph you can give your y. Because this is an histogram. Histogram will only need one particular variable because it's a count. We are counting the number of values under a variable. So, but for other type of charts like bar charts, you will use y. You have to give the value of your y in this particular aesthetic function, which is inside the ggplot function. So this is for plotting a minimal epidemic curve inside R. So now we want to now plot weekly epi curve by outcome. So this is also the epidemic curve, but now we are plotting weekly epi curve by outcome. So now in this case now, we're not just plotting a simple epidemic curve. We now want to look at it weekly. And aside from looking at it weekly, we also want to look at it by each outcome. That is by those that died. I think that was what was on our outcome. So those that recovered and those that actually died. So we're going to be looking at it. Those that recovered and died. We want to see how the epidemic curve looks like in both outcomes. So the first thing we're going to be doing now, we are going to create another variable called epiweek. We are going to create another variable called epiweek. So it's like we're creating a week based on our data. So if I run this now, and I view the line list, so you can see this is the week. So if you look at this now, if you look at the intervals between this and this, so look at this, our epi week variable that we have now. We are trying to create it by week. So let's say, for example, now, how will I put it? It's like we're looking at the dates now. So all of these dates fall into this particular week. So when does the week start? When did that week start? So also this particular is just going to look at the calendar, and each date is going to like record the date that particular week started. So that is just what we're just trying to do there. So you just use your demutate function. You create the variable epi week. And we have this particular function here called floor date. So where you give your date onset and you give your unit as week. Then you say week start is 1. So if you look at the floor date function now, so it's a way of rounding up date types. So when you have date types in R, how are you going to round them up? Because they are not numbers. So this is where you use your floor date. So it takes the following arguments. The first is the date that you're trying to actually apply it on. Then the next is also your units, which is in week, and also have the week start. So if you look at the week start, so the default is usually 7. So Monday carries 1, then Tuesday carries 2, up till Sunday that carries 7. So which day do you want your week to start? So the day you want your week to start is what you're going to just give in that particular place. Then you now get the week that particular date falls into. So I don't know, is it clear? Or it needs more explanation?
Is it like every week we say every week 1, 2, 3, or every Monday we carry 1? I'm getting confused about it.
Okay, if you have your date already, it's going to okay, let me see the date now. Okay. So I think this is I think what do we use? We use date onset. Yes, 2026-06. Okay, look at this now. Your date of onset. Look at the first one. 2026 3rd, 20th 3rd, 2026. This is our date. Now, the week starts 16th 3rd, 2026. If you also look at this one, we have 11th 5th, 2026. The week starts 11th 5th, 2026. It's more or less like you have dates already. You now want to get the week because we are trying to look at the epidemic curve weekly. So you have to now create a new variable whereby you get the date that week started. So all the dates you already have, they fall. R is going to check that particular date that you have. It falls under which week in the calendar. And you already told your R that your week should start on Monday, not Sunday. So your week is going to start on Monday. So it's now going to pick that Monday date as the beginning of the week. So it's already recording it weekly for you. So each date is going to give you the date that it falls on the week. So you already have the first one now, which is 20th 3rd, 2026. So which week did it fall into? So you're not recording it as week 1, week 2. You're not recording it as that. You're recording the dates that week started because you actually need that date. So your week started on 16th 3rd, 2026 for that particular individual date onset. If you go back to the next one, the date of the onset was 11th 5th, 2026. And 11th 5th, 2026 fall on this particular date where the week started because the week actually started on 11th 5th, 2026 also. So I don't know if it's clear.
Yes, it's clear.
Okay. So that's it. We already have our epi week now.
Sorry, hello.
Yes.
Hanifa Umar, please kindly check if you received the email. Sorry, I omitted his name. Thank you.
Yes, ma, I've received it. Thank you very much.
Now, we already have our epi week now, just like we needed. So the first thing we are going to be doing now, we are going to now start creating the plots. So GG plots, line list, or let me just do it like this. So let me pick this first. And
Sorry, sir. Sorry to bother you. Does it mean it's not going to, the weeks are not going to follow each other? Like, because I saw that it's skipping the weeks. That's why it was.
Yes, that's what I'm trying to say. You know this, if you look at the data now, as I'm looking at it now, the weeks, it's not as if the data is even, it's just records of individuals. Somebody might be in number 1, but his own date is even late than another person's date. So if you look at even the date itself, you can see this is 5th, it's coming after 6th. It's not as if the date is even arranged. So what you are just trying to create, you just want to know under which week does each date fall. It should just pick you the date. So let me just. So this, for example, now this is July 2026. We had this patient with date of onset on 8. Now we want to know what was the date of the week. Or let's say 9th. The person's date of onset was 9th, July 2026. The date of that week is 6th, July 2026. For someone that had an onset on 17th, July 2026, the date of the week of that onset is going to start from what? 13th, July 2026. So it's speaking like each week, he's picking the Monday, each week. It was already specified that our week should start on Monday.
Okay, I understand. So if it will end up plotting all the Mondays of the weeks, right?
He's going to play, yes, he's going to take it as a week that, okay, these are the onsets that happened on this week.
Okay, sir. Thank you. I got it.
Okay, so now this is our GG plots already. You can see another case now. Now, in this case now, I'm filling by outcome. So what fill by outcome means is that you should color my graph by outcome. We will not see the results now. Let's put the remaining layers. But it's just trying to say that what for each particular week that we have, we should give me the outcome, both those that recovered and but that means for every week that I'm going to be seeing now, I want to see those that died and also those that recovered, because I already have my data weekly now. So I'm going to use my plus sign. I'll now say Jomba. So Jomba, now I'm going to give it the color white. So this color, I told you that color is usually the outline. Color is usually the outline. So take note of that. So you can see my Jomba now. Now, this is what this particular thing means. This field is equal to outcome. Let me remove it so that you can see the difference. So can you see the difference now? I not put field is equal to outcome. I'm only getting the number of cases for each week. You can see the graph has become condensed now because I'm using weekly. I'm no more using daily. Daily was what I had earlier on. That one I was using date onset. I was just using each date onset. But now I'm using it weekly. So you can see now the graph has become more condensed. You can see that each particular value you see here is for what? Weekly. It's for weekly. It's for weekly. Now, if I decide to now put that color by outcome, what I want to now see is in this graph is that out of those people in each week, how many died? How many recovered? That is why I'm saying field is equal to outcome. So out of these people, each of them here, it's happening. So out of each of this, how many died, how many recovered? You can see from January to April, most of them actually recovered. But in this particular place, which is this is around June, March, May, June. This is around May, June. You can see these are the number of people that died, and these are the number of people that these are the number of people that died. These are the number of people that recovered. And we have our missing values in this place. So these are missing observations here. So in each particular week, we have missing observations. We're going to take account of them. So all of here now, we have around 60 plus. So these are the amount of people that, just from our graph, we just know that a small frequency of people died in this particular place. So we only have cases in these particular weeks. We only have cases in this particular week. So we're not done with the graph yet, because I'm very sure some of us will be wondering the axis, how we can make the axis more comprehensive. Now, the next thing we now want to do is scale fill manual. So we have this scale fill manual. So when you run this now, it's like we're just trying to color our scaling more. So you are manually, just from the name, manually fill the scale. So you have your values here from your outcome. What this scale fill manual actually does, if you don't like the color that your plot is coming with, and you want to change the color to something more expressive, then you use scale fill manual. So it has two values. First of all, you give the values in your column. And which column are we talking about? We are talking about the column we use for filling the bars. The variable we use for filling the bars is outcome. This is it. We use this outcome to fill the bars. I can decide to use word now. So you can see this is, okay, I'm not supposed to, let me remove this so that I can show you how it works with the word. Can you see this is with word now? So in terms of word, this is it. We can see each word, the total number of people in each word, total number of cases from each word, you can see it. So this is how that field works. So in cases, you might not want the way the color of the field actually looks like. So that is where you now use that particular scale field manual. So what are now the values under my variable that I'm using to fill? My values under the variable I'm using to fill, which is outcome, are 2, recovered and died. So I'm now going to use these values arguments under the scale fill manual function. I'll now say recovered is equals to C green and died is equals to fire brick. So these are some kinds. I think there's a documentation about the colors in app. You can explore various colors for your graph. So sea green and fire brick, these are the 2 colors I'm using. And NA.value means what color am I giving missing values? So I'm giving missing values gray 70. So gray 70 is the number of a type of gray inside our inside R type of gray color. So this I will now come up with this particular graph. So you can see it now. This I will come up with this graph. So the next thing that we now have is our labs. So I think we already understand the labs. We have okay, where is it? Okay. So these are our labs now, which is actually the next thing in line. And I've already explained it earlier on. That your labs is just labels, your title, then your x-axis, which is week of onset. Monday is the starting day of the week, the number of cases, then your outcome. That is this particular legend that you have in this place. So when you run this, you can see you have a proper looking graph with all the labels properly put in place. You can see the weekly epidemic curve by outcome, number of cases, the week of onset. You also have your outcome. They also have this particular place. Most of these are just a way of just styling your graph. I already talked about the team minimal. So if I to put team minimal now, so you can see that particular shaded place is going to disappear once I put team minimal. That particular gray shaded area here. So you can also even put other teams. There are different kind of teams. There are dark teams that you can use. They have their functions. You can go through that. Maybe after the course, most of the links might be sent to some of the documentation to explore some of these functions, because ggplot2 actually has a lot of functions. So it's one of the libraries, packages that have a lot of functions with. And you can use it to plot any kind of graph you have. So then we have team axis. So what does this does is just to slant your axis. It slants your axis. That's what it does. It slants your axis. I don't know, please, you guys should give me a moment. Come.
Okay. I think at this point, I want to use this opportunity to share some information. Hello, Peter. You want to ask a question or
I also want to ask a question.
just record? Okay, yes, you can go ahead.
Okay, so the first epidemic of he used a histogram, and the second one we're doing he's using a bar chart. So now because I think we use Jomba, right, for this one. So I want to ask why is that? Why the difference in the chart type?
Okay.
Okay.
Rehan, are you there?
Yes, I'm
Okay.
there. Okay. The reason
Okay,
why was
go
that
ahead.
technically there are two different things, histogram and bar chart. But there's something we want to achieve in this place. Because the histogram doesn't actually, is not actually used for categorical variables. So we want to consider our week as a categorical variable. And we can't achieve that using the histogram. We can only achieve that using the bar charts. So normally, the bar chart and the histogram look similar. So if you look at them now, even by looking at it, one might not know what was it a bar chart that was used or it was a histogram that was actually used. So the proper function would have been the histogram, but we're actually trying to look for our epidemic curve colored by outcome, which can only be achieved using a bar chart and not an histogram. So that is why we decided to use a bar chart and not the histogram. But if you just want to do a plain epidemic curve, you can go ahead with the histogram. I don't know if it's clear.
I follow now. Thank you.
Okay. So I think this is it for this
I have a
particular.
question.
Okay, yes.
So the labeling in the one you just plotted, that starts with the week.
Yes.
I was also trying to see whether I can see the labeling for each of those columns. I'm seeing only January, April. So if you say it is a week, I was expecting to see like AP week 1, just the labeling and this thing having 1, 2, 3, so that at a point in glance I can see the week that has cases instead of them just being only January, April didn't make it clear. I don't know whether it can be labeled like that.
Okay. Okay. The thing is that it's going to use there's this particular function. Let me try if I can see, can recall it. I think it's scale date, I think. Let me see it. I can actually just let me see. Let me see. Scale X dates. So scale X dates are supposed to give some arguments. Let me check it. So let's use this one. This. So I think so. This was what you are trying to refer to, right?
Yes.
Hello? Yes. So this was from last year. I think that's why it's showing 52. Now, this is the function we use. But you see this function, it depends on what you write inside. So this is just a simple, you can actually do more than this. Date breaks, you can say I put 1 week here. Okay, let me just go to where it is. You can see date breaks can put 1 week and date labels should be what? In week. This label should actually be in week. You can decide to put the date itself you can decide to put the week itself. So this is one of the functions that you can use. So that's what I was trying to say earlier on, that the ggplot actually has a lot of functions. Functions in ggplot is one of the packages that has a lot of functions, because they are actually, in fact, even this plot that you see we did, there are functions you can use to put the values to show in this place and even position them so that they are proper. So you can actually use those functions to put the values here, put the values here, put the values here. So I think, let me show you people a chart. Let me see if I still have them with me. It's just some sample charts. I don't know.
Ridwan, while you're looking for the chart, let me quickly do kind of go through a presentation.
Okay.
Yeah.
Okay.
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 So you have it now?
Yes.
Okay.
So this is one of the plots that you can plot with ggplot2. This was actually plotted by ggplot2. Even the watermarks that you see on it was done using ggplot2. And the other functions for that, I will show you the code for that also. I think, let me see here if the code is in this place, scripts. Okay. So you can see how it is looking. You can see how much is it. How that of the, you can see the functions, some of them here. You can see some of the functions here. You can see some of the functions in this place. So there is you can see some of the functions actually used. So it's a very comprehensive package. It's not as simple as the ones we have been using, like the dplyr, the other packages that we have actually been using. So it's something that you can use it beyond your imagination. And also, I think I will encourage you people to follow what's this particular, can you help me remind me this Julia Silge's every week that they used to do? These visuals they used to share every week.
So Tidy Tuesday?
Yes, Tidy Tuesday. Yes, Tidy Tuesday. Tidy Tuesday. So it's best, I think, I don't know, I've not been seeing them on Twitter. I think they went back to this particular social media. Was it Trade or something like that? They went there. So I think it's best to search for it. So each visuals that are shown, you see some complex visuals, they usually give the code out. You can look at the code and use it to do what you want to do. So this just, in summary, this is just the function you need for you to be able to break those particular dates. So you can see it's actually, it breaks the date into numbers. If you want the actual date itself, you can put it like that. If you want the actual date itself. So let me just even remove this and see what do we have around this. So you can see these are the actual dates, the weeks. So you can see them. If you don't want it in that week one format, you can get it like this. So it's just anything you can do. You can build anything in ggplot2. It's just your imagination that matters. I don't know if it's clear.
What if we want to make a map?
I have a question, please.
Yes.
What if
How
we
can
have
we?
week and month?
Okay, please. Who is talking? Okay, are we there?
Okay, so yes, hello. So how can
Yes.
we actually, because how can we actually familiarize ourselves with some of the functions? Like, where can we get more knowledge on how to use ggplot2 to our best satisfaction? You understand? Because I think I'm actually seeing this is for the, let's say, not for very long time now. I'm just seeing it. So how can we like learn more and even be able to do some other comprehensive stuff on that package? Thank you.
Okay. You need to build plots. You need to build plots. Any data you see, try to build beautiful, not just simple plots. Like this one we did earlier on, just a simple plot.
Okay.
You need to build, you need to push yourself to build complex plots. And advice we give, maybe since we're already in the era of AI now, you can just ask AI to give you a publication ready plot using ggplot2. Once you put the word publication ready plot, It's going to give you a very comprehensive
Okay.
prep. And you start studying the functions. You start breaking it line by line. You start from the beginning when you have those kind of functions,
Plots. Okay.
scripts. You start removing it. For example, now let's take this as a code to build a plot. You start by removing all of this first. You start from the beginning. Then you now what? When you understand that line, you go to the second one because the thing works in layers. It works in layers.
Okay.
So once you start seeing the way it looks like from the foundation, you start understanding what some of the function does. Okay, this is what it does. This is what it
Does.
does.
Okay.
This is what it does.
Okay.
And one funny thing with ggplot is that you can even see functions inside here. Like look at this one we did now. It's a function inside this ggplot that you're looking at. You need to know,
Okay.
understand what it's actually doing. So this is what it's doing. This is what this particular function is. Then you now go to the next layer. And I also say you should follow that tidy Tuesday. So even if you go to
Tidy
Twitter,
Tuesday. Okay.
you go to Twitter, you see their previous post. So every visual that somebody gives, the person always release the code. So you check the code and you see how that particular visual was done. So that's how you just start getting familiar with all those functions. You can also use them in your own visualizations.
Thank you. Thank
Yeah,
you.
welcome. Nice.
Please kindly give me like 5 minutes or less than
Okay,
that.
yes,
So I
no
just want to
problem.
quickly go through a
Yes.
presentation here. Okay.
Okay, I should off my screen share.
Thank you. Yes, stop sharing there. Okay. Okay. Thank you, everybody. I think we're having a nice time together, and we really appreciate your time. It's the weekend, we should be resting, but we have to continuously upskill. So thank you to all those who help us in filling the forms for the feedback. We really appreciate your comments. Well, that really got us excited to do more. So I want to go into a bit about us, and I think that's where we'll be able to move forward. Like the question that just came in, how can we progress or get more knowledge? So I want to go through the slides. So next one. So let me just do this slideshow from the beginning. And based on the feedback we got yesterday, I quickly want to go into who we are. So I'm Bilikisu Olatunji, and I'm the founder and co-organizer of the Abuja Art User Group here in Nigeria. And I believe most of you would have gotten access to this information through that platform or a sister platform that is also supporting the R community, maybe from other states. So we are based here in Abuja, and we have a lot of requests that, okay, we want to learn how can you support us and all this stuff. So that's why we decided to create this. And we know a large percentage of our community are based within the public health sector and the epidemiology sector and the related fields around that side. So that's why we decided, okay, as the sponsoring company, that's Business Data Laboratory, we're going to push out this free weekend course. So, and based on the feedback, we'll be able to know how we can support the community more. We are independent consultants and we collaborate together. So, for me, I'm Belikesu Olatuji. I'm a data scientist. So, I use R, use other tools as well. So, but we're talking about R today. So, the second person here is Ifeoma Eboha. She's based in Lagos, but she's part of the Our Ladies Abuja community. She's been a very supportive member, and she was willing to really support this initiative. That's why we're in this together. She was here yesterday. I think today kind of maybe tight. She wasn't here today. So, and Ridwan, kind of, I want you to tell us a bit about you again in this video.
Okay. So my name is Adejimo Ridwan Suleiman. I'm currently the one taking the 2-day disease surveillance and outbreak analytics course. I'm a biostatistician. I'm also a data scientist, and also one of the, let me just say, one of the community members of Abuja User Group, and I'm collaborating with Mrs. Bilkis at Business Data Laboratory to just pass the gospel of R and also data science in general. Nice meeting everyone.
Right. Thank you so much. So we have a lot of independent consultants within our community, but we three volunteered to kind of chair this initiative. So we work as data scientists, consulting for different organizations, and we are available for that. So, but for the community, we need to empower ourselves. So that's why we're coming up with this one. So I'll go to the next slide. So the Abuja Data and AI Polyglot Community. Polyglot in the sense that we don't want to stick with R. A lot of learning are coming from our members that will talk about the other aspect as well, like Python, Power BI, and so on and so forth. So if you join the community, you'll be able to have access to this community right now. So, based on the feedback that we got yesterday, thank you so much. We really appreciate you, and we are happy that we're able to deliver on this 2 days workshop. Even for the first day, we have a pass mark. So, from the 3 feedback responses, we have feedback that the short course is relevant to what you're doing right now as a professional. So that 100% of you want it, you want more. So the total, what we are data scientists, we work with data, so we need to get insight from what you gave to us. So it's not just about using it for any other thing, but we need to make sense of what you're telling us through the data you gave to us. So a lot of you, from the percentage that we're having here, the relevance to your work is key from the value that you can see here. And 97% of you would recommend the training. That means we did well with the first day that you interacted with us. So that 100% of you want future training updates. So then the confidence using R after day 1 really went a little bit higher than where we started, because we got some information from you when we started, and right now we're doing great. That at least that maybe the fear of, can I really cope with R? That one is a little bit down now. So the pain that we see that you guys have is that R is relevant, but the confidence is still developing. So many participants need installation, syntax, and practice support. So then the live coding needs for recording, scripts, and guided labs. So you need this more, like the last participant asked, how can I get much more better using ggplots? You need to practice and learn more. You need somebody to guide you. That's what it means. So what we heard from you in simple terms is that I want to learn R, but I need one to start from the beginning and slow down. Where kind of you felt maybe we're fast yesterday, but I think today we're doing better. Then you can see value, but following the code live was not always easy. Yes, we get that. And I need outputs I can use for what? Research and reporting. So based on this, we've come up with a practical class that we're going to be starting soon. So we want to base this on the feedback you gave to us. So in this course, it's going to be like a 4-week course, but we are still going to get feedback from you on the days that is preferable to you guys. That is it going to be Saturdays only or Sundays only, or Saturdays and Sundays? So whichever one is preferable, then we want to get the feedback from you as well. So in this upcoming class, we're going to learn about R basics, clean the health data, analyze indicators, visualize findings, and we're going to create reports, reproducible report that is not going to scare you, but at least you can push something out there. So we promise you by the end, you will know how to import, clean, summarize, visualize, and report public health data using R with confidence. So these are the modules that we're going to be having there, and we're going to break it down. And each of the modules is going to have a lab. You have to practice. We said practice makes perfect. You're going to practice using some labs that we're going to give it to you. So, and we're also going to review that. We're going to give you feedback, and you will also have a final project that you can just showcase anywhere. So this is a breakdown of what we're going to have. I don't want to take much of our time so that we can finish, but you can see that each model will have a lab by itself. So what will make this course different is going to be that it's going to be beginner friendly, going to use public health data, we will have guided labs, the recordings and the scripts will be shared with you. The portfolios are going to be kind of reviewed and guided as well. Then you also have the community support. You'll always be in our community that where we can support you as you move on. So you'll get your portfolio and you also get the certificate of completion so that you can use within your career. So I know I'm kind of rushing, but I want us to use the time, but I just have to chip this in because this free class is not going to help you go far, but it has already started you on a journey of fulfillment that you're confident that still is not that scary just for me to get used to it. So we're going to recommend a 4 weeks class. We're going to share the information with you by email. You'll have the 2 live sessions per weekend. But if you don't want it, we will want to let's just do a quick survey in the chat that okay, Sunday should be out or the 2 days is okay for us. For those who are interested in the training, it's going to be a paid training session so that we can give in all to help you really get there. Because we're all working, we have our projects that we're working, we do our consultancy, but we have a community that we need to strengthen. That's why we're coming up with this. So that is all I have for today. So it's a trust. We are going to keep our promise, and this is what we are going to do. So we'll share the details with you later, and then we can take it from there. So thank you so much for giving me your time, and I think this is where we're going to stop. Thank you so much. Ridwan, we can take it up from here. Okay, thank you.
Okay. Thank you for that. Okay, where do we stop? I think. Okay.
Okay, thank you. So there's going to be a certificate after. I saw some questions here. So there's going to be a certificate after that, and you have your portfolio, you have codes, you have support of the community as well. So thank you.
So I think we have done the weekly epic off by outcome, which is just achieved, and we have already seen how it looks like. So now we're going to be faceting by word. So that's what we refer to as faceting. So faceting is just a way of saying splitting your graph into various groups. So let me just run this to explain the concept of faceting before I explain the code. So this is how faceting looks like. Yeah, faceting means to split your graph based on a particular category. You can see we have various words here. Agodi, Apata, and Bodija, Sango, Ring Road, and so Road. So this is just how the faceting looks like. So first of all, the first thing you're going to do is your ggplots. Your ggplots, you can see it. Then you add your geombar. You add your geombar. This is your geombar. We have already put the fill as dark orange. So when you are using geombar, in cases whereby you're not filling by a variable, then that is where you now use fill inside the geombar. But if you can see this former plot we just did, we filled by a variable. So that's why I did not put fill inside here. So we just put only color. Color is just the color of the outline of the bar, not the fill itself. Color is for the outline. So here we're using dark orange for our geombar. So this is how the epidemic curves look like dark orange. Then we now put a facet. A facet, we apply facet wrap. So facet wrap is used when you want to facet by, you have 2 types of faceting. We have facet grid, we have facet wrap. Facet wrap is when you want to use a variable to facet. While you have facet grid, this one is where you now manually split your bars into maybe 1, 2, 3. Like you decide the way the grid will look like. Like earlier on when I did this, you can see it. Facet wrap is automatically just going to do it for you so that it's going to accommodate this particular environment where the plot is. So you now specify the variable you want to facet with, which is by word. So when you run it, you can see you have this. I can decide to specify by, let me say, by sex now. Let me say by sex. So you can see this is a facet wrap by sex. This is how it looks like, facet wrap by 6. So it's just a way of splitting your plot into various groups using this particular facet wrap function. So I'm going to leave it as the by word. Then labs, I'm very sure all of us are already familiar with the labels, how we use the labels. Then all of this also. So this one changes let me explain this again. This one changes the angle of your text. It's going to be slanted. So once I bring this now, the angle of our text is going to change. You can see it's now slanted. So the angle of this particular text is slanted. And if you still want it to show you by the week, that you want those week 1, week 2, then you can just do what we did earlier on. Okay, let me add it here. Scale X axis. Let me add it here for those that might need it. Scale X dates.
Okay, I think somebody is asking that you maximize the screen. Maybe in
Okay,
case
the
the
screen is
font.
small. Is it the plot or the?
Is it the font?
Actually, the sharing is not like before. Like you just see. I don't know whether it's from my own part, but you just see the screen just at the center of your screen. Like it's not as large as before when we have the classes yesterday and today at the beginning. So I didn't know what happened. Maybe it's from my side or it's from your side.
Well, I don't know. Are you the only one having that issue, or everyone is also having that?
Yes,
It's
it is not
okay
full
now.
screen.
At my end, it's okay.
It's
Yours is
okay
okay?
at my hand. Yes.
So I think it's be from the settings of the device or your Zoom settings there. I don't know. Yeah. This is not a general issue. Can I
Okay, I'll
proceed?
check it. I'll check it here. Just proceed.
Okay. Okay. So okay, I've already added this now. So if you decide you want it to be, you can just decide to add it in this place, the scale X axis. So there's one more thing also. You can Google I'm coming. ggplot2 cheat sheets. Yes, I think this is the one by R Studio. So you can Google ggplot2 cheat sheets. So you can see them here. I think yes. In fact, if you can even just have these and print, to actually help you a lot. This is ggplot2 cheat sheets. So these are it looks like. You can see in terms of these are the basic functions that you need. We have the various type of geoms. They don't list all of them. They only list the important ones. Then we have lines. We have the types of variables there for plotting. If you have continuous variables like age, like weight, height, you use this kind of graphs. So it's very comprehensive. So you can download the PDF. It's free. It's from our studio github.io. Let me even share it in the chat. So I think that's it. So you can just download this. If you also want to understand it, you can even print it and just go through it or look at it. So you cannot actually memorize all this. It's just as you get used, your memory just gets to fix it with time. So you get to know which one you can use. You can do a lot of things with this. Okay. So that's it for that particular weekly epidemic curve faceted by word. So we are able to see, go back to the graph now, we are going to see which word is actually having, you can see Iwo Road now. Iwo Road is having 20 cases around this particular site. So that means most of our cases were even coming from Iwo Road, if you look at it very well, obviously. So the other ones, like places like Agodi now and also Ring Road, you can see the number of cases are not that much. So the importance of this faceting is that by looking at your epidemic curve, you already know that June and May are having high, we have high cases, prevalence of cases. So the epidemic curves, the faceting allows you to be able to now look at which word is actually having that particular high cases. Because you might have high cases and you notice that out of 10 words, it's actually one that is actually having that particular issue. The remaining ones are actually normal. So this is the importance of faceting in R.
Sorry, but why is June and May not labeled in the graph? Why is it
Yes.
April, July?
That is the work of this particular function. That's what I was telling you earlier on. This particular, where is the function that I did earlier on? This scale X date. This is where you control everything that happens there. How you want the graph to show it. Do you want the graph to show from January to December? Do you want it to show only quarterly? Do you want it to show weekly? So this is the function that actually controls that. You can see the name, scale X dates. Scale X dates. So R is just giving you by default. R is giving you by default. If you actually want it to be more, that's why I think this will even be a good follow-up exercise after this, for you to just look at it. How can you actually tweak this particular function to be able to show you the way you want the date to look like? Do you want it to show all the date itself? Or do you want it to just show it quarterly, or you want it to show it for you weekly so that I can know where and where is actually? So if I decide to just use this one now for this is actually the weekly on. So let me just use it here and see. So I decide to run it. So, okay, let me just remove this now. I just use the dates. Let me just use the dates. So there's a reason why sometimes you might not even want to use all, just to make your graph much more simpler to see. So you can see now in this place, I'm just using only the dates. I'm using only the dates. You can also decide to show it in, I think, that of monthly. Let me see if that of monthly was giving me 1 month. Let's see. So I think this for 1 month. Okay, so now this is monthly. You can see this is for January, this is for February, this for, if you wanted to give the month names, you can also do that in that setting, in that function. So here is just giving the pure date. If you wanted to actually give the name of the month, you can also do that. So up to, this is it. So you can see it's ending in each particular, because this is another new graph. So it's ending here, July. So the new graph starts from also January, because each of these are, the scale changes when you go to the next graph. So this scale represents a column. For all the value, the plots in this column, you use this scale. For the next one, you use this particular scale. For the next one, you use what? You use this scale. So anything, the way you want your x-axis to look like depends on what and what you actually put in this function. And you can learn more by just looking at the documentation of the function. This is the documentation of the function. What and what does it carry? You can also see examples on how you can use that particular function. I don't know if it's clear.
It's clear. Thank you.
Yes. Okay, so we have what we call attack rate. We're going to look at key outbreak measures. So attack rate is just your new cases in a period. How many cases do you have in that particular period? So a period is more or less like the timeline, let's say a date or a week. How many cases do you have? And how was the population at risk at that particular period? Then you multiply it by 10,000. So it's like per 10,000. The number, that's how you define the attack rates. So we're going to be looking at that. How can we calculate attack rates from our data? So first of all, you need to create or you count the number of cases. So you can see attack rates now. The first we are looking at attack rates by word. That is cases per population. Attack rate by word is what we are looking at now, per 10,000. Attack rates by word per 10,000. So there's this function we have called count. So if you look at our line list here, or let me decide to just run this so that we'll just see what we are looking at. Cases by word. So what we just did in this place is just a fast way of summarizing your line lists. This is another way of just creating a frequency, cases. So each word, how many cases do we have? For each word, you can see the number of cases here. You can decide to change this to sex. I can decide to change this to sex and just run it. You have to view it now. So you can see now for sex, these are look like. So this is like another alternative, that particular table we did. This is another way you can also create a frequency table in R. Just like that table that we just did earlier on. So we have our cases by word now. So these are cases per word. 27 for Agodi, 46 for Apata, up to Sango, you have 70. Now, we want to now calculate the attack rate for each particular word. Attack rate for each particular word, we are going to be saying cases by word. Then left join. For those of you that have used SQL, we have what's called left join and right join. So left join means that this is your data on your left-hand side. You want to join it with another data, which means any ID that is in the left table. You have two tables, left and right. You have IDs in the left, you have IDs in the right. When you say left join, it means that any ID that is in my left, match it with the one on the right and bring the data. But if there's an ID that is not in my left, but it is in the right one, don't bring that data. I only need the IDs on my left. We also have right join. Right join is when you have your IDs in your right, and you now say you want to join with the table on the left. Bring me the data that the IDs are on this right table. Even though there's an ID in the left and it is not in the right, don't bring that data because the ID is not in the right. So that means you are only going to be having IDs on your right. So that is what the left join or the right join is. There's other types, full join, but most of the time what you'll be using is the left join. The left join is what we're going to be using. So now we are doing left join. We want to do left join. I don't know, for those of you that might have come later on, we loaded this data. Population, this is it. This is population, and these are cases by word. Population, cases by word. You can see them. So we're going to be doing a left join. This is our left. Cases by word. This is our what? Right. So we want to do a left join such that we will have a single table where we have word, we have cases, and we now have population. So that's what we're going to be doing now. So we're going to go back.
Is it because the word is on the left side? So we want to join word and word that are all on the left side. Is that what you mean?
Yes, that's what we're trying to do. The word is not like our ID. So we want to join that word.
If the column for word was on the right side, then it would be the right join.
Okay, let me do it like this now. This is our two tables, right? This one is on the left. Is that not so? And this is the one on the right. Now, let's say we have another place in this. We have another word here. Let's say, for example, now, Monia or challenge is in this place, number 7. Let's say we have number 7. It's inside this particular data. Now, our cases by word only have this. We don't have challenge or Monia in this place. So at the end, the table that we'll finally get is not going to include that one that is in this place. But assume it was right join we are using, it's going to include the one here. It will now record it as NA because this one did not have the one in this place. You know, this is the one that's having an extra word. If we are to use a right join, we will now have in our final data. Okay, let's do it and see. I think we see it practically. We understand better. So here, our right table is population, and by word is what we are using. We are using by word. So you can see we already have the data in this place. Now, if you look at this particular data now, this population, let's say, for example, now population add number 7 an extra word or 2 more extra words in this place. And if you wanted to do a left join, the left join is going to take into consideration the one on the left-hand side. That is what the left join does. It takes into consideration, that means the priority is the one on the left-hand side. So if there's an extra word in this place, left join will not bring that extra word. It's only to just give you the word in this place. But if I'm to use a right join, for example, now, a right join, I think let me look for a table. I'm trying to, okay, let me look for this particular, I think it's deep layer, tidy iron, deep layer, tidy arrow. There is a particular diagram they have. I'm looking for the diagram. There's a diagram that you have. I'm trying to look at it. I think this is the diagram I'm looking for. Okay, not even this one. Okay, let's use this one. Yes, I think we can see this diagram clearly. Can we see this clearly?
Yes.
So this is left, right, and full join. This is the left one, the one on the left-hand side. This is the one on the right-hand side. You can see ID. This is our ID. This 1, 2, and 3 is our ID. This is for the left-hand side. This 1, 2, and 4 is the ID for the right-hand side. If you look at this left-hand side, it doesn't have 4. If you notice, there's no 4 here. So when you do a left join in this place, that 4 will not come up in the new table. It's not going to come up. Now, this is for the right join. The left-hand side is having 1, 2, 3. While the right-hand side is having 1, 2, 4. When you do a right join, it's only going to put in consideration the right-hand side. So that means there is no 3 on the right-hand side. So it's not going to give you 3 in the final table. That means, according to R, I don't recognize 3 to be part of what I'm going to give in the final table. Now, for a full join, the reason why it's called a full join, whether there is 3 in this place, or there is no 3 in this place, or there is 4 in this place, there is no 4 in this place, it's going to bring all of them. So the one that doesn't have value, to just put NA there. That means I actually joined it, but there is no value for that particular ID. So left-hand side, just take it as this. It's only going to consider the IDs on the left table. Right-hand side will consider the IDs on the right table. While full join is going to consider all the IDs together. I don't know if it's clear.
Yes, but what of inner join? Is inner join same with the full join?
No inner join. Okay. Think there's no example of inner join here. Let me
Also,
see.
Ridwan, is it in the code that you know which one is on the left, which one is on the right? Is it based on how you write it inside the code?
Yes,
Okay.
I will show you. Let me explain the inner join. Then we'll now go to the the code. What inner join does? Okay, look at this. Look at this table now. Which of these particular IDs is common between the two? Which ID is in both tables?
1 and 2.
So that's what inner join does. It's going to pick only 1 and 2 in the final table. It's not going to, it's going to drop 3, it's going to drop 4. So that's how inner join works.
Okay.
Excuse me, please.
Okay, any question or that's all?
Yes.
Okay.
Please. So I'm just thinking about something.
Okay.
Based on before she has that question about using the code or something. Is it that
I'm not hearing you clearly, please. I don't know.
Hello, can you hear me now?
I think it's somehow echoing, I think. I'm feeling an echo.
Okay, let me.
Yes.
Can you hear me now?
Okay, I think you can just speak now.
It is also echoing from here. It is also echoing from my side.
Or you can just chat it up if it's possible to type it. I don't know.
Okay, I'm hearing you. Can you hear me?
Yes, I'm hearing you now.
Okay, so is it that the first table that you wrote
on the code. Let's say the what as the population and what you run it
Yes.
first, case by what and case by population. So let's say you run case by what before case by population. So isn't that the case by what that you start loading when you call that will be the one on the left? Or it doesn't matter which code came before the other, which table come before the other.
Okay. I think I know what's happening. Now, because we're using the pipe operator, but this is how the function looks like. Left join. Cases by word. Then what? Then population. This is how the function looks like. Even the one of the right join also is the same thing. Right join. It's also the same thing. Cases by word. Then population. This is how it looks like. Left join and right join. Left join and right. This is how it looks like. Now, is the function that is you that will decide. Is the type of function that I use that will let R to know which of them is going to use as a priority in merging. And like this now, you have to give your buy by what? If you are okay, let's say for example, now I have another table that's having case ID, another table that's having case ID. Maybe that other one now is now having more information on each particular individual. You are going to be using this by what? So now this arrangement you are seeing, if you look at this arrangement now, you can see cases by what came first is one on the left, while population is one on the right. If you switch it, that means if you are using left join, if I switch it now like this, left join, population, cases by what? If I switch it like this now, that means population has become the one on my left, while cases by what has become the one on my what? On my right. So that means if I have an ID in this place that is not in this place, it's only going to give me the ID of this place if I use left join. If I decide to now use a right join by changing this position now, if I decide to use a right join, this is a right join. Now, if I decide to use this right join now, it means that what is going to make this one to be the priority because it's the one on the right. So that means if an ID is in this place and it's not in this place, I will not see it in my final answer or my final data set. I'm not going to see it because it's only taking the IDs that are in this place. That's the priority, the ID that is considering. I don't know if that answers your question.
Yes, please.
Okay. So this is you can also write it because I use the pipe operator, that's why we not write it like this, but you can also write it like that. So I think that's it for the join. So now when we join the data now, we can see what we're having when we join the data. Population is already there now. So we now use our mutate because we want to create a new variable called attack rate. Attack rate per 1,000. So attack rate per 1,000 is the number of cases which we already have in our line inside this place. You can see our cases. Cases divided by population. Then you now multiply by what? 1,000. Cases divided by population per 1,000. When I run this, you can see what we are having. Supposed to be like, I'm coming. Supposed to concept of board notes. Okay, I think we still have the same thing. Okay, so now we have our cases divided by population times 1,000. So 1.3 cases per 1,000, approximately 1 or 2 cases per 1,000. Now we want to now round it up to the what? To one significant figures. That's where the round function now comes. You want to round it up to one significant figures. The round function will take all of this, and the next argument you give after the comma is going to now be the number of significant figures you want to leave it as, whether 1 or 0. So we can just even leave it as 0. That is to the nearest whole number. So to the nearest whole number, we're going to be putting 0. function is supposed to be here. So you can see this is our what? Attack rates per 1,000 in each particular word to the nearest whole number. So you can now arrange it in descending order, or you want it to be more detailed, since we can still leave it as the one. We want it to be more detailed, since we are going to also arrange it in descending order. So you can leave it as one. Then we now say arrange descending order attack rates per 1,000. So this is what we now have. We can see our attack rates now in descending order. So you can see we actually arrange it in descending order by attack rate. We not do it by cases. We not do it by population. We did it by the attack rate. So this is the highest, which is in Iwo Road. And you can see our graph is already telling us, because Iwo Road, the graph we did earlier on, you can see Iwo Road was one having a high number of cases around this particular period. So you can see the attack rate is also showing what? That it has already confirmed what the visualization had earlier on. So this is how you can calculate your attack rate. Then the next, we are going to plot the attack rate by word. So our attack rates, we are going to use ggplot to plot it. First of all, we give our attack rates. We are going to plot it by, we are going to plot a geom column. Now, the difference between geom column and geom bar. Geom column and geom bar are two different things. So let me just run this for you to see how the geom column looks like. Okay, I think I've not calculated attack rate. This is how a geom column looks like. They are both the same thing. It's just that one have the x-axis to be vertical. That is the geom column. In the geom column, the x-axis is vertical, while the y-axis is what? Horizontal. While in geom bar, the x-axis is horizontal, while the y-axis is vertical. So that's just their difference. So when you are now trying to give this, if you are plotting a geom bar, this x will become your y. Or if you want to make this particular x now, if you are plotting a geom bar, it's going to become your y. Why the y will become your x. So this is what makes them different. So they are both bar plots. So now, in our geom aesthetics here, I told that this is where you're going to be giving your
Bring it, let's share it. So you want to corner it, only you.
So this is where you give your values of your axis. So for this particular x-axis now, we have, so we can see a particular function here called the reorder. So I'll show you what the reorder does when we finish the graph. But just take this as our x-axis, which is attack rates per 1,000. Attack rates per 1,000 is our x-axis. Word is our x-axis here. This reorder is why we use this attack rate by 1,000. I'll explain the reorder. But word here is our x-axis, which is this place. Why our y-axis is the attack rate by 1,000, which is the values. So now, we now add our geom column function. We are giving it tomato color. So we have various colors in R. Then cohort flip. So let's do it like this now. Now, so if you look at this now, you can see what we are having. It's looking like a bar plot. If we now use cohort flip, it's going to flip it. If I'm to switch this or swap this now in this place, let's do something here. So can you see what's happening now? Geom column. I told you that the x-axis is going to be your attack rate in geom column, while your y-axis is going to be the word. So now, what we now did in that other, what we did earlier on now, we did cohort flip. Because if you look at it, we swapped it. Which means you can even use the geom column and the geom bar. You can use them interchangeably. In fact, you can use, just by switching the axis and cohort flip, you can achieve a geom column using a geom bar function, using a geom bar graph. You can also use the geom bar to achieve the geom column. What just happened is just the issue of the axis. It's just that in a column graph or a column bar plot, your x-axis is usually your categories. Your x-axis is usually your values, while your y-axis is the categories. While in a vertical or horizontal, I think we call this our horizontal bar plot. While in the vertical one, your x-axis is going to be your categories, while your y-axis is going to be your values. So then the next thing that we'll now do is our labels. We're already used with the labels. Then the next thing that we do is team minimal. So once you just plot this, sorry, I not put the cohort flip. So we now have this particular graph that we're having in this place.
Okay, sorry, please, what's the null in that? The null x equals null, please.
Okay, which side?
In the label,
Where?
in the labs.
Okay, yes, that means you should remove the X label. That's what you see. Let me remove it and you see what's happening. Can you see that X now has a label? Can you see it? But once I put that particular null, it means remove the label of X. Is it clear?
Yes. Yeah.
Now, back to this reorder. I said I'm going to explain the reorder. So let me remove reorder now so that you see something. I think just by even looking at it, we should know what the reorder does. What happened now shows us what the reorder does. The reorder function. You can see the graph now is no more sorted. It's just scattered. So that's what the reorder actually does. So the reorder function, you use it when you are trying to give your axis. So it's going to reorder the word by attack rate. It's a way of using this arrange and descending, but when you are inside a plot, this is how you use it. You use a reorder. When you say reorder word, attack rate by 1,000, so it's going to show you the word with the highest attack rate to the word with the lowest attack rate. So this graph now that I'm looking at now, this plot, you can see it is not arranged. It's not showing us the ranking of the attack rate. But once we use reorder, we are able to look at the ranking of the attack rate. So you can see the highest to the lowest. And this is one of the principles when one is trying to plot visualizations. You always make it very easy to interpret a visual. Just by looking at it, one can know that this is what is the highest, this is what is the lowest. Is it clear?
Yes.
Okay. So next is case fatality ratio. So case fatality ratio, we have total number of deaths divided by total number of cases with known outcomes multiplied by 100. This is case fatality ratio. So we just want to know the CFR, that is just the deaths with respect to those. That is just a way of measuring those that die with respect to the number of cases. That's just the case fatality ratio. So the case fatality ratio, we also want to calculate it too also. So first of all, line list, which is our data. Then we have filter. Filter now, we are removing NA. That is what we are trying to do. Any outcome that is NA, we don't need it because now case fatality ratio is deaths to the number of cases. So we don't actually need NA. Any value that is missing, that has NA value, it should remove it. That is what it means by what? Filter. If I'm to say is.NA outcome, it means give me only values that are NA. But once I say, or once I put this exclamation mark, it means not. That means don't filter or don't give me values that are NA. So this is one of the logical signs that is actually used in R. So if we run this now, you can see if you go to our graph and our table, if you look at the outcome, you're not going to be seeing any NA. See no NA in the outcome. So compared to what we have in the line list, if you check the outcome, you can see we're having, you can see NAs are here. So I've already removed the NAs there. Now, the next thing that we now want to do is to what? We have a function called summarize. Because we need to know the total number of, let's say for each particular day now, or each particular date, we need to know how many people died in that day. We will now divide it by total number of cases for that day. We'll now multiply by 100. So this is where summarize actually comes into play. So let me just say summarize now. Summarize. First of all, let's start with this. Total with known outcome, which is n. Let's put it as this. So when we run this, you can see we're having 287. Total with known outcome is 287. Of all the individuals we have in our data, 287 are with known outcomes. Then we now look for, we react sum outcome is equals to died. Okay, so this will be double. Now, out of all the outcomes that we have, these are the totals with known outcome. And this is the total number of deaths that we have. So you are dividing, the case fatality ratio is deaths by total number of those with known outcomes. That's why you see you have to remove the missing ones. So these are the, so we're going to divide 8 by 287 to get our case fatality ratio, which is what we now did in this place. So deaths divided by total with known outcome, then multiply by 100 based on our formula. And we see we are using the round function to round it to two significant figures. So when we run this now, we now have what? 2.79 is our what? Case fatality ratio, which is the total number of deaths divided by total number with known outcome multiplied by 100. I don't know if it's clear. Is it clear?
Yes.
Okay. So the next is now proportion of those that are hospitalized. So this is also other indicators, proportion of those that are hospitalized, and also timeliness indicators. So how fast was an outbreak being responded to? So for proportion of those that are hospitalized, we're also going to filter those that are what? Missing. We also use our summarize function. So summarize is just a way of calculating or summarize just from the name. You are summarizing values in your data set to get a single value. So under proportion of those hospitalized, we're now going to say the mean of those that are hospitalized is equals to, okay, let's put it like this now. So how many people were hospitalized in our data? We now count the total number of those that are hospitalized. We get the mean of them, and we multiply it by 100. So let's do it step by step and see. Line lists, okay, let me just copy this. And let me remove this. Can also do it like, let me just, before I put the mean. I think it counts. So this is the total number of those that were hospitalized. I use sum. So we get the total number of those that are hospitalized. So then we now get the mean of those that are hospitalized, which means we're going to be adding each person this 118. We have 0.4, 0.413. 0.413. Then we now multiply it by 100. We have 41.3, and we also round it to the what? It's even already in one significant figure, so we might not even need to round. It's already in one significant figure. So if you want to get the average of number of those that are actually hospitalized, so this is how we do it. So we're going to go as going out to our table. I think okay, yeah, this is it. So this is so. So that's the average or the proportion of individuals that are actually hospitalized. Then for the D part, we have the mean/median reporting delay. So what's the mean delay? You know, we created a variable called reporting delay. You can still remember this is it. Reporting delay. These are reporting delay that we created. So we're also going to summarize, and the mean delay is going to be the mean of the reporting delay. What's the average of the reporting delay? Just like we did in the previous ones, the average of the reporting delay, and it's going to remove missing. That's why I'm putting this. And because in the mean, I'm going to put in na.rm is equal to true. That means remove missing values. Don't consider them. Then we now use the round function to round to one significant figures. Median delay also, you just change it to median. Median delay, you change it to median. So median, you don't need to round because reporting delay is actually in integer. They are not decimal. So we don't have I don't think we have decimal in the reporting delay. It's just the difference between these. So we don't need to round it. Then we have maximum delay too also. So maximum delay is going to look for the maximum of all this reporting delay. What's the maximum of this reporting delay? It's going to look for the maximum values. So, and it's going to now return these three values for you. So you now get to have this. So this is the mean delay, this is the median delay, and this is the maximum delay. So I don't know if it's clear before I move to moving averages. Is it clear? Okay. Then let me go to, I think the next we have moving averages. So moving averages. So moving averages is just a way of, let me put it in this way. Okay. So let me arrange the date onset. Let me explain this, please. Then I can now talk about the. Okay, for also to do the moving averages, ensure you have this installed, the zoo package. So because it's not a major package, that's why I not put it initially, but just make sure you have installed it. And this is the way you refer to it. If you don't want to install it, you don't want to load a package using library, you can just use the function of the package by calling the package name. For example, now scheme R scheme. So if you don't want to use library to load the package, if you are using it only once in your code, so and you don't want to load the package, you just refer to the package name. Using that double colon, you refer to the package name, then the column function of that particular package. So we have our line lists, and we have our line lists. Then we have our counts. So count is used to count the total number of cases for each particular date onset. I'm giving it the name cases. If I don't give it a name, I just do it like this. This is it. So it's going to give it by default n. So because given by that's why I need to put the name is equals to cases. So it's now going to give you the name cases. Then I'll now say complete. So the complete is just a way of turning the missing values. Date onset. Sequence.date. So the minimum date onset, maximum date onset by date. So if we are to view this, let's view this first before I now, so that I can see how the complete works. You can see how it works. If you look at this date onset now that you see, there are some dates that are not there, if you notice. So if you look at this particular, so that's what we're trying to do now. We're trying to complete it. So when I run this now, let's just copy this. Now let's run and see. Now, the former one I showed you earlier on, there were some dates that were not there. So we need to fill those dates because we want to do a moving average. And a moving average, which is daily, means that you need to have each date from January to July. But even though there are no cases in that day, you need to just have those dates in your data and record them as 0. So that's what the moving. Please try and. So that is what is actually trying happening. Please try and mute your mic. So that's what we did in this place. We are completing those missing dates. So when I was doing, this, you can see some dates, 7th is not there, 8th is not there, up to 19th, they are not there. So we need to fill them because we are doing a moving average. So I'll explain what the moving average is now. So let's just have the data we're going to use. Then we now arrange it in descending order. Arrange it in descending order. The date onsets. So it's going to be in ascending order because the higher the date is, so it's not in descending, it's going to be in ascending. The higher the date is, so we're going to start from 5th of January, 6th, 7th, you can see it's already in ascending order. So now we already have our data now. Now we want to calculate a moving average. So now what is a moving average? So moving average, we're going to calculate a 7 days moving average. So moving average means that for each particular day, we're going to get the average of the past 7 days, including that day. So let me do it like this now. We can't get a moving average for this. We don't have any days before this. We can't get a moving average for 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 this, but we can get a moving average for this because we are using a 7 days moving average. So for a 7 days moving average, we are going to be adding the total number of cases. 1 plus 2 plus 0 plus 0 plus 0 plus 0 plus 0 divided by 7. That's why it's called moving average. They will now put the value here. That's our 7 days moving average. For now, this 8th one, the moving average is now going to become 2 because now we have already done for this, which covers 1. So I'm going to say 1, 2, 3, 4, 5, 6, 7. So for this one, the 8th one, the moving average is going to be what? The sum of all the cases here, then divided by 7. Then for this 9th one, we will now pick it from number 3. This, you count it up to 7, which is on the 9th one. You add all the cases, divide it. So that's what is called the moving average, a 7 days moving average. If we were using a 3 days moving average, this one we not have, this one we not have, but this one we have. If we are using a 3 days moving average, it's going to become 1 plus 2 plus 0 divided by 3. If we're using a 4 days moving average, this one we not have, this one we not have, this one we not have, but this one we have. 1 plus 2 plus 0 divided by 4. So that is what the moving average is. So going back, hope the moving average concept is clear. Okay, are we there?
Yes.
Okay. Okay, then so that's what so now we're now going to create a new value called moving average, which you are seeing what we are going to do here. So we are creating a new variable called moving average. And this is the function you use, rolling mean. You use roll mean. And by what? By cases. Is your cases that you are actually interested in. What's your moving average value? 7. Then those other ones, would you want to fill any value for the missing observations? No. You put NA. So that means missing observations will have what? NA. Then you align it by the what? By the right. It's going to show by the right. So once we run this, so you can see, just like I told you earlier on, the moving average will start from number 7. Now for the ending, so you can see for up to the last one. So the moving average is going to start from number 7. Because all these ones can't have moving average because the number of variables before it is not up to 7, including it itself is not up to 7. So it's only the 7th one, the moving average will start because we are even using a 7 days moving average. So this is how you can calculate the moving average. So it's just a way of knowing the what? So you can see this just you know for the past 7 days, what's the average number of cases? That's what moving average means. For the past 7 days, what's the average number of cases? So for the past 7 days, this is the average number of cases that we are having. You can see it. So this is what the moving average actually means. And this is how you can do it in app. So at the end, so hope is clear before I just finalize with this. You can also, I think there's a plot too also. We have a plot for it. So for the plot, this is it.
Sorry to break in. Please, please
Yeah.
don't forget to sign or complete the feedback form because a lot of people sign up for the program, but not everybody participated. So we want to give only those who participated. Please, that is your attendance sheet. Please, we're begging you, just fill that form. We don't want to just give it to anybody, please. Thank you.
Okay, I don't know what's happening. Let me just see. Let me just start from the beginning. So I think I might have a particular code that is blocking the graph from showing. Same cases not found. I'm surprised. Let me see the daily cases. Okay, this is where the issue is. Okay, I think I've seen the problem. Okay, so this is the moving average graph now. So this is the moving average. Daily cases with 7-day moving average. So this is how we did it. First of all, we have our daily cases, which is our data. Then we have our axis, which is the daily onset, because that's what is going to be on our x-axis. Then next, we're using geom column. We're using geom column, and whereby our y is the number of cases that we have. That's our y. And we are filling it with what? With gray 80 column. Then we have another graph. So that's the interesting thing with ggplot. You can combine graphs together. Geom line. Geom line is now where you put your moving average values. So you also use the aesthetic function too to specify your moving average value, which is your y-axis, which is moving average 7D. This is it, moving average 7Ds. Then you give the color as dark blue. Then the line width, that's the thickness of the line, as 1. Then you put your labels, then just tin minimal. And you have this particular graph here. So this is your moving average that you have. So this is a 7 days moving average. The total number of cases after, average number of cases after 7 days. This is the graph of it. So then this is just a one-page surveillance summary. So we have a total. So we are creating a table here. This function is used to create a table in R. Using the tidyverse function, we'll call it table. This is going to be your column. So, and this is going to be, this is going to be your first column. This is going to be your second column. So if I should run this now, so you can see what we are having. So you are trying to create a column. So the total number of observations, total number of values here must be equal to the total number of values in this place. Because each value here, or each label here, represents a value in this place. Here's the total number of cases, which is represented by n row line lists. Then we have date range, which is represented by what? This. Then we have words affected, which is represented by this. We have overall attack rate, which is now represented by this, which is the attack rate we had earlier on. So it's going to be the total number of the observations that we, total number of observations we have divided total number of population in that data that we had, that population data. That's your attack rate by 10,000. You know, the one we got earlier on was attack rate by word. What is now the general attack rate or the total attack rate? Then also have our CFR here, CFR percentage, because our CFR is in table. This is the CFR. So that's why I'm using the dollar sign. I told you that the dollar sign is used to select a column inside a table or a data frame. So that's how we got this. Then we have this one, which is the percentage of hospitalized. This is the percentage of hospitalized. Then we have what? The reporting delay. So when you run all of this, you get this particular what? Table. So this is like a what? Just a one table reporting summary of all of one table or one page surveillance reports that we have. These are total number of cases, the date range, the wards affected, overall attack rates, case fatality ratio, hospitalized, and also what? The median reporting delays. So I think this brings us to the end of this particular course. So beyond this, you can actually just automate all of this using R Markdown and Quarto. And just like she already explained earlier on, those are actually going to be covered in depth in the full training programs. So I don't know, is there any questions based on all what we have done now?
It's beautiful. So you have questions,
Okay.
concern? Thank you. Thank you so much, Ridwan, and that was a good one. Thank you, everybody. Thank you. So please, if you don't want to give certificate just to anybody, fill this form. That is your attendance sheet, I would say. I know some people have filled the form. I've seen that, but please don't leave without filling the form. The form is here, and please, we would really appreciate it if you can complete that. Then we'll be able to share with you the certificate of participation and the resources. I know the code has changed, so we're going to update the repo, and you'll get everything updated there. So please, the, the form link. Okay, please kindly try again. Please kindly click the link and let me know if you can access it. Okay. I think it's working. Kindly click the link again and let me know. Please kindly fill it again. Please, I'm begging you, please fill it again. That is the attendance. Please fill the attendance again, please. Yeah, okay, I know there's a lot of sections where you have to put in so much, but I don't think um, there's too much in encouragement. You can always encourage us with good words, um, good feedbacks and everything. So please. Okay. So please kindly help us. Just give it the time. I think we also did a great job giving our time 2 days. It's not a joke. So kindly give us that feedback to encourage us, please. So I'm sharing the link again. Yeah, let's just take it as attendance. So, good comments. If you have any feedback, just let me stop recording.